We've got a massive deep dive ahead of us today. We are jumping into something called the Dillon equation.
And it's a big one. This is a theoretical framework that aims to, well, fundamentally rewire how we think about energy, information, the whole universe.
So our mission here is to really unpack that, to understand how it proposes to unify these concepts by making one really radical shift.
Redefining the speed of light.
Exactly. That's the hook. For what, over a century, modern physics has relied on the speed of light, type $dollars, being this absolute global invariant.
The universal speed limit, right?
And the Dillon equation just says, no. It argues that the Stallers is actually dynamic. It changes depending on local gravitational curvature.
Right, and if you assume Stallers is constant, you get these huge structural problems in cosmology.
You're talking about things like the horizon problem, the flatness problem.
The horizon problem, the flatness problem, and that, that lingering Hubble tension. Standard physics has to kind of bolt on ideas like cosmic inflation just to make the math work.
But hold on. A constant CDR has worked perfectly fine for decades, at least in our little corner of the universe. So why exactly do we need a new framework beyond just tidying up old cosmological models?
Well, because the mess is pretty fundamental. What's so fascinating here is the idea that in really high curvature domains, like the universe moments after the Big Bang, the speed of light would have been vastly higher than the toy dollars we measure today.
And a higher speed of light back then means what? Causal horizons expanded faster?
Much faster. It means different regions of the very early universe could actually communicate and thermalize naturally.
So a variable speed of light basically replaces the entire theory of inflation.
That's the proposal. It's an enormous hypothesis.
And I also saw the sources suggest it tries to resolve the need for dark matter.
Yes, and that's where the link to curvature gets really powerful. The framework suggests that the strange rotation of galaxies, how they spin faster than they should.
Right, the rotation curves.
Can be explained by how geometry itself modulates propagation. You don't need vast, invisible halos of dark matter providing extra gravity. The geometry is already doing the work.
Okay, this is a lot. It claims to solve inflation in dark matter, but the really surprising part for me, reading through this, was the connection to energy.
This is the practical aha moment.
Yeah, the claim is there's a massive, untapped reservoir of usable energy stored purely in the geometric gradients of space-time itself.
Exactly. The curvature energy identity. It basically says energy is tied to how distance changes relative to changes in space-time curvature. This is revolutionary. I mean, it implies non-mechanical energy extraction is possible.
So we can pull energy directly from the shape of space. The example they used was tidal refractance, which is a challenging concept.
It is, but think of it this way. Traditional tides are about the kinetic motion of water, right?
Water being pushed and pulled.
This framework reinterprets tides as manifestations of curvature refractance. Space-time itself is being slightly bent by the Earth, Moon, and Sun system, and if you can tap into that continuous, predictable geometric stress,
you have fuel-free power.
You have fuel-free power.
So let's bring this home for everyone listening. What does this actually mean for, the multi-trillion-dollar markets this technology could address?
The implications are pretty immediate. First, you have something called curvature engines, or CVEs.
A whole new category of tech.
A new category that couples directly into those geometric gradients. This is huge for the tidal energy market, which right now is bottlenecked by needing massive, complex mechanical turbines and so on.
And the second one was orbital engineering.
Yes. If you can use geometry for propulsion instead of mass expulsion, instead of propellant, you get indefinite mission life for satellites.
Propellantless propulsion. That would radically change the economics of the entire low Earth orbit economy, which is projected to be over $1 trillion.
Absolutely. Indefinite missions become viable. It's a total game changer for space logistics and exploration.
So, tying this all together, the core takeaway seems to be that by treating the speed of light and energy as functions of geometry, you could decouple energy from combustion and information from these fixed constraints.
And the ultimate goal that the research talks about is a societal one, a transition to what they call a type I curvature coherent civilization, one that masters space-time geometry for its energy and communication needs.
Which leaves us with a final provocative thought for you to explore next. How do we actually prove any of this? What are the specific real-world experiments that could validate this shift away from constant phase physics?
The sources point to extremely precise measurement. Developing interferometric probes to look for tiny variations in Salar-Z's, and measuring specific electromagnetic and refractance signatures in solid planets. That's how you'd prove these tidal effects are truly geometric distortions, not just mechanical forces. That's the evidence we need.